All right, hey there, pre-calc. We're going to deal with some transformations. A lot of this should be pretty familiar to you. We've dealt with in Algebra 2, um, stuff like this. So we know the inside part here is going to move us left and right and it's opposite. The outside part, that's going to move up and down and it's true. If we have a number out in front, so let's throw in -3, right? So that negative means it's going to be upside down. Remember, our academic term is an x-axis reflection. And the fact that it's 3, well, 3 for that a value is greater than 1. So that means it's going to be a vertical stretch. And the only reason we bring it up is because we're going to deal with a lot of those things. So this equation is essentially the same thing, right? So your a value, that tells you whether it opens up or down. If we're going to get a vertical stretch or vertical shrink, right? Right, we used to call it compression. We have the same thing here. But now we have something inside as well. And here's what happens. Now we can also describe this graph as being horizontally shrink or horizontally stretch. Now these things are going to be inverses. Okay, so if I am stretched horizontally, okay, that means it's going to shrink vertically. Right, so think about that. As we push a graph together, it's going to ooze out the sides. And then the same thing the other way. So if I stretch it this way, it's going to be compressed. So I'm going to try and highlight these. So if I stretch it vertically, it's going to shrink horizontally. Right? So think about that idea that if you squish a Oreo cookie, I don't know why you do that, but if you squish an Oreo cookie, like the cream comes out the sides, okay, and versus stretching things out. So that's probably the newest thing that we have here for you. Notice what we have is the outside is going to move up and down. So that's what we're used to with this -4. I'm running out of highlighter colors here. And then that left and right idea, that plus C. So we're going to fool with that a little bit because we're also going to throw in a negative on the inside there. And that's going to give us that y-axis reflection. We tried not to deal with it too much in Algebra 2, but now it comes back to get us a little bit. So there's a couple new things in here with some old things. So we'll work our way through it and deal with it that way. All right, and we'll try and give you a shortcut as well. All right, so old school stuff, it's inside the absolute value. So we know absolute value is that V shape. And this one is +5 on the inside. It's the only thing going on. So we know it's going to go to the left 5 units. All right, we have a couple things in V. It's going to be an x-axis reflection. And what else do we have? We have +6, and it's going to move up 6 units. So those are the translations. That's what's going to happen between the two. All right, the next one we have is a square root. We're relatively familiar with square roots. And what happens is now I have a y-axis reflection. And that goes in combination with a +3. Okay, so typically for a +3, I would say left 3 units, right? But when these things happen together, we really want to think about what happens to my domain. So those two things are absolutely correct. Okay, but if I solve this and I divide by -1, I don't know why I have so many negatives there, x becomes less than or equal to 3. Okay, so where is that? That's actually to the right. So think about what I had. This ends up being right 3 units. Okay, so let's talk about what we originally had for this problem. We had a y-axis reflection and left 3 units. Well, if the y-axis is vertical and I went left 3 units and I have to do a reflection, that is right 3 units. So there's kind of our way around that is we just think about if it's inside, we're going to talk about what makes the inside part of it equal to 0. I chose greater than or equal to 0 because it talks about our domain for a square root function. All right, so the next one we have is we have a 4 placed on the inside here. So we know that has a pretty good impact, but there's a way around this one as well because we really want to think about this thing getting taller no matter what's going on because it's multiplied by 4. But since it's the square root, remember we can do this. What's the square root of 4 and the square root of x? Well, that's 2 square root of x. And now it becomes an a value instead of a b value. And we're much more comfortable with those. Okay, so for this one, we're going to use this idea. So this is a vertical stretch. okay, which we could consider a horizontal compression, which is what they wanted right here. Okay, so a horizontal compression, HC. So I know they use shrink and stuff like that. I like the idea of stretch and compress. Gives us some different letters so we can abbreviate a little bit. And I think they make more sense that way, right? Because if it's been vertically stretched, that means horizontally it's got to be compressed or skinnier. Right? And the square root of x, that just tells us about the shape. So a vertical stretch of 2, okay, or it's a horizontal compression of 4 because we left it in here. So depending on which way you have to match a multiple choice, that's the way we would deal with it. All right, back to something we're familiar with is the square root. All right, and this is plain old inside. So hopefully by now we know this one is going to go to the left 2 units. All right, so here we have the double talk with it. Right, we have a y-axis reflection. And what normally would happen, since I have a positive 6 in there, right, so think about solving it this way. If we're going to look at domain, negative x equals negative 6, so x equals 6. So where is that? And this is truly what happens, is it ends up going to the right. But a positive 6 would typically take us to the left 6 units. Okay, or these two things mean that we're actually going to go to the right 6 units. Okay, so, but if I have to describe it based on what's there, right, so in a description, I need to give these two answers. If it's an action, if it's something I need to graph, I'm going to go with, okay, that just means right. All right, so we have our table. All right, so here we are talking about horizontal translations. Notice these things are insides, that's left and right. These things are outside, so they're up and down. Okay, then we start doing our multiplication. So we know this is an x-axis reflection. If it's multiplied by negative on the inside, that's a y-axis. If it's both, that means we flip it around the origin. That means it was x and y, which would flip the whole thing around the origin. Okay, and then we tried to simplify this horizontal stretch and compression as much as we can, along with vertical. All right, so what we're going to do is we're going to put some new functions in front of you. Okay, I'm going to start with the natural log. We probably studied natural log a little bit in Algebra 2, but we didn't ever really looked at the graph. So let me see if I can't find a page that has that. Okay, here we go. Okay, so what's the natural look like? Natural log looks like this. Okay, so it's one of our functions we worked with. Now the first one that we have on our OneNote is just multiplying it by 1/2. Okay, so that makes it an A value based on its location. So that means it's not going to be stretched because we multiplied it by half. So what we'd like to see is a compression, right? We want to see this vertically compressed or horizontally stretched. But based on the location in the equation, since it's 1/2 right here, that means we want to talk about it as a vertical. Okay, so here it is. Now it's the blue one, so it's been squished a good bit. Okay, so I'm going to jump back and forth a little bit. This should be on the side here. So this is an A value. So this is a vertical compression of 1/2. Okay, and the next one, we have x plus 4. It's inside these parentheses. So that means it's inside part of the unit. So we're going to work with saying that that's left and right. And since it's a negative 4, that means, or if it's positive 4, that means it's going to go to the negative. Got ahead of myself there. So that means it's going to be left 4 units. That got all squished together. Okay, so left 4 units. All right, and if we're kind of unclear about that, then what we can do is go back. I'm going to get rid of the 1/2, and here's my plus 4. Boom, look at that. Here it is, way off here. So we're trying to look at some of those similar points. So where is -1? Or I'm sorry, 1 is over at -3. That's a translation of 4 units to the left. So if we're not sure, we're going to pick one of those nice points and kind of move it around. So that gets us through a couple of those. All right, let me get those out of the way. And the next thing that we have is e to the x power. All right, so this is the basic function. This is our basic function. So it kind of looks like the natural log, but it's flipped around. That's because they're inverses, right? So the first thing we have to do on our OneNote is then take this thing and it's multiplied by 4. Okay, so that means it should be stretched. So that part's going to be a little bit different. So let me, as a matter of fact, let me add that in here and we'll take a look. So that moved and made it a little bit taller. But then what we're going to do is it has x plus 2. Now here's the one that's different, is normally we want to see things in parentheses to know that they're going to move left and right. For our function dealing with e, if it's in the exponent, this is your left and right. Oh my goodness, I got ahead of myself there. All right, we'll skip, we'll come back to it. Okay, so I'm going to highlight this part right here because that's what we're talking about. And this means left 2 units. And we had said this was an a equals 4, so that's a vertical stretch of 4 because it was not listed anywhere else. All right, so that gives us our first one. I promise we'll go back to those other ones. All right, taking a look at our other graph now. So let me get this one out of the way. So remember this one here, let's take the 4 off. So this is our parent function. Now what we'd like to do is we're going to take the exponent multiplied by 3. Okay, so that's like having a 3 inside. Okay, so that means we're technically talking about a horizontal stretch or compression. So let's see what happens with it. But I also have a plus 2 on the outside. It's not in the exponent. So that means that we should see it move up. Okay, so here's the up 2. And then if we look at the other one, okay, what do we believe that to be? Okay, so horizontally, we've compressed it, right? It's going up a lot faster, okay, because it looks like a vertical stretch. So that's why these two things kind of overlap just a little bit. Okay, so the 3 gives us a horizontal compression of 3, plus 2 gives us up 2 units. All right, so those are kind of the newer functions. So I want to make sure you had a chance to see those. Some things that I hope are review. So here we got 2x minus 8. Okay, so the 2 in here is kind of new, but remember what we're going to do with this is I know that it should go to the right. If I didn't have the 2, it would go to the right 8 units, but that's not going to happen here, right? So let's figure out exactly how far it is going to go. It's only going to go 4. Okay, so that means it's 4 units to the right. All right, but it is going to be that U shape because that is the squared function, the quadratic. It's a parabola. Okay, and how do we deal with that? So at first, we would say that it is going to move to the right 8, but it has this horizontal compression. So it's not really going to get that far. It's only going to get to 4. Okay, so end result. So description and functionality are going to be 2 different things that we'll deal with here. All right, for letter B, we got down 3. And here, this negative is on the inside. So that means it's a B value, which means it's a y-axis reflection. Okay. So that means we won't really see anything different because we didn't move left and right for this parabola. So it'll actually look the same as just down 3. Okay, but as far as describing it, those are the things we'll have to use to describe it. All right, now we get a brand new function. We looked at it as part of our parent function and what's going on here. So let's first take a look at what's going on. So our sine function, remember that's the one that does go through the origin, right? Cosine does not. And the very first one, so we'll just, even though it's brand new, let's see if we can apply this. So if it's multiplied by 3, right, what we really want is if anything else is multiplied by 3, that means it's going to get taller, right? It's a vertical stretch. Well, I would say that's vertically stretched, okay? And the factor was 3, so we can deal with it that way. So this means that we had that a value of 3. It's a vertical stretch of 3. We made it taller. Okay, so in the next one, we're going to take 4, and notice it's on the inside. So this is going to be horizontal. And we know it's of 4, but here's the idea that we're still working out. Is that going to be a horizontal stretch or a horizontal compression? And that's what I have these graphs in here to try and help you out with. Okay, so here's the original, right? Here's our parent again. Okay. And what you'll find is that this thing's been squished together because if we take a look and we really focus in, saying, well, how far is it for the cycle? So if I were to try and look at just one of these locations, okay, so if I go from maybe the local max here to the local max here, right, I'm gonna have 1, 2, 3, 4. So I have 4 more peaks inside of here. So we're making a horizontal compression, right? We multiplied it by 4. Look at that. So that's kind of a neat idea. right? Because the 4, it made it cycle 4 times within that time frame that we had the previous one. All right, now our next one, so we're not really used to pi divided by 2, but if it was just plus 2 in there, right, so this is just how we have to deal with our trig functions. If it was just 2, you'd say left 2. So this is actually just going to be the left pi over 2 units. Right? And I do have the graph in there, so we can double check that in just a minute. But in the next one, so we have an x-axis reflection, because this is before the entire function starts, so we're multiplying by negative. So in other words, right, that's our fancy word for upside down. And then plus 2 is after everything, so that means it's up 2. Okay, so those are 2 things we're going to check. So first one is just that plus pi over 2. So let's get rid of multiplying by 4. So that means everything went to the left, right? So if I use the origin as my vertex point, right, kind of an idea of what's going on, that means this point moved to the left. Okay, I'll buy it. All right, and the last one, we said it was going to be upside down, but moved up 2. Which sure looks upside down, right? Because, you know, where we had valleys, we have peaks now. So it's upside down. And has this point moved up 2? Absolutely. So if that point has moved up 2, that means each additional point has been moved up 2 as we deal with those. All right, so that's kind of our new functions. So play around with any of those functions that you need. It is embedded in your OneNote, you know, but I know sometimes that bogs down the video. So I had to go back and forth, but we should have those. All right, linear functions. I hope we're okay with these. So we know this is going to be up 3, and this means you have a negative slope, but that means it's an x-axis reflection. Okay. And part B here, we have it's going to go down, negative slope. So again, x-axis reflection. The A value is 1/3. Okay, so that's a vertical compression, right, because it's going to be squished. And then we know this is going to be down 4 units. Right, so those are all the things that we're trying to deal with. We do have some mixed review here, some inverses. So we'll guide you through those real quick. Remember, this is the same thing as y. So we're going to go with x equals 3y squared plus 2, and then solve. So I get x minus 2 equals 3y squared. Divide out the 3. And then the last step, how do we get rid of the square? We're going to take the square root. So what do we call this? This is the inverse of f of x. All right, the other review that we have, we'll kind of let you check in. I'll get them set up and then check in with the answers in class here. 2x plus 3 minus 3x squared. Okay, so this is a monomial, so it's not a big deal, but I did put parentheses to show that substitution. I don't have any like terms, so if I were to rearrange it, I do have to start with negative 3x squared. In B, okay, f of x, so that's 2x plus 3, and it's over 3x squared. So here we might add in, okay, what do I have to do for the domain of this? All right, and in our last one, so this one's open. So that does not mean multiply. That means I have to take g and substitute it in here. So 2, I want to put in 3x squared, and then plus 3 to finish out the function of f of x. So we'll distribute, and then we won't have any like terms. Again, we could talk about domain, but we know it's quadratic, so there's not really much to do there. All right, we got a couple homework problems. I did highlight them this time. I'm trying to get better for you. All right, have a good day.